Hey, hello there. Recently I was going through some old photos and I came across a folder from sculptures in Japan. And I found this sculpture and I was very intrigued. I didn't know where I took it. I think it was somewhere in Tokyo, and you have a sculpture garden where you can see them. I don't know the artist yet, but it looks very interesting. You can also see very clearly the topology of all these panels which are bolted together. So I found this very nice visual, and I was wondering, could I make this in geometry nodes as a procedural system? So I went into Blender and I made two versions, and I'm going to show you the nodes that I used, and also you can get them on Blender Market in the bundles that I made. I have the engineering bundle, I'm going to put it in there, and also in just the geometry nodes beam constructions, I'm going to put it there as well, so you don't have to purchase it separately. It's in these tools if you don't want to build them yourself, so it's actually quite easy to build them yourself. Here you see all the nodes. I'm starting off with this donut shape, and I'm triangulated. When I connect this, you see that this is a twisted donut shape that is just standard in Blender, and I am triangulated. I can also dual mesh it, so you get these hexagons. I have it with an icosphere, so you see it works really well procedurally. So let's keep the triangulated one and then see what I'm doing here. So first I'm capturing the index of the faces. So if I make a viewer node, you can see that these are the basic, this is the basic geometry and the topology. So there are no extra lines, these are the lines, and I'm capturing these lines. Now I'm also capturing the position of these points, and then I am setting the position by a multiply of the normal. So I'm actually bringing the whole mesh inward. And if I'm doing this, here you can see, or actually I'm pushing it outward because I'm extruding it inward. So next I'm splitting the edges. You don't see any change because they stay in the same position. And then I'm extruding them by 0. So there's now extra lines on the lines that were already there, but also in the same position. And then I'm resetting the position by the initial position that they were over here. And then you see that you get this effect. And I'm doing this because when I would just extrude the faces, then you would get like the seams wouldn't be in the same position. So I can show you here, if I take a triangulated one and I make an extrude node, you already see that they don't align. Like this face, these inner faces, they must be aligned, or else you get like panels that are not connected. There's a V shape between them, or they are like inverted and they pass through each other. So I needed these faces to be exactly aligned, because they are going to be separate panels bolted together, so you don't want any gaps. And that's what's happening here by setting the position. Then next I am extruding them to give them thickness. And then next I'm flipping the faces of these panels, so the extruded panels, to move them inward, and then I'm joining them together. And this is something I used, which could be handy, but I don't use it anymore. That was like an offset, like the same as extrude, but in a slightly different way. But I found that the extrude worked a little bit better. And then next what I'm doing, because these faces, the faces that I'm starting with, and these faces and the extruded faces that you can see here, to give them thickness, they are separate. And I'm capturing here the face index And actually these faces and these faces have the same index, so I can connect them again. If I just say merge by distance, then everything will be connected because everything is very close together. And here with the repeat zone, if I delete this one, the viewer node, with the repeat zone, I take the index and I'm adding an index by every repetition, and it takes every face. Here you can see that I capture the domain, the amount of faces, so it repeats the amount of faces that are in this mesh. And then I'm deleting everything and keeping only the face and these faces with the same index, and I merge them. So if I can disconnect this, maybe also take away this one, then you see that if I say 1, this is what it does. So it takes these faces and connects them. And if I do the index, you see it does that for every face. So here you see what the procedure does. So if I put this at 0 again and then plug in the iterations, it does the whole thing, and now every panel with its flanges are connected. And then I'm realizing the instances, and here in the top I'm doing the bolts. So I'm also shading them smooth, so it looks like a nice edge, and I even have a bevel on here. I do that after the geometry nodes. And then here in the top I am taking from this one, after capturing the position of the points, I'm here extruding them. If I use a viewer node here, so I have these edges again, and then I am deleting like all the geometry except of the top edges. So this is deleted, and the top edges are staying. And then I am extending them, or actually pulling them in, so I can put the bolts in here. And then I'm doing the same thing here, but then for the other one. So this is the top lines, this is the edges without the inner faces, and then I'm using that to sample the normal, so I know which direction the bolts need to go. And then I'm putting the instances. I have here a rounded cylinder, which is over here. If I zoom in, you can also use just a regular cylinder or an import of a screw or a bolt, something like that. I'm flooring it, centering it, so it's right in the middle, and then I'm using it as an instance with the alignment of the Z, and I'm using the vector normal that I sample from the closest surface. So if I then take this away, you see that all the bolts are here aligned. I'm also using a resample node for the curve, so I can give it less or more bolts. So if you get larger faces, then you get more bolts, leaving this at 100, and then you see the distribution. And this is the extend edge node, and it works like this. So it just takes it makes a curve, and I capture the tangent, and then I'm pulling in the endpoints or pushing out the endpoints of the curves, and that's what I can do here. So you see that they get closer together like this, and now because of the resample it's filling in more bolts, but I leave it at -40. So that's how this setup works. Here you can see it in full, and you can make it yourself or get it at Blender Market. I also put a shiny material on it so it looks metallic. But when I made this and I looked at the photo, I see actually something different, which is that these panels are curved, and this setup only works with flat panels, gives every single face the flanges. So then I was thinking, Okay, how do I create these banded panels? And that's slightly different. And here you see I'm using a solidify and a bevel, and when I take these one off, you see that I only have these flat edges. And it's nice because the solidify has these more complex ways of extruding, so everything has the same thickness, which is why I use this. You can also do this in the geometry nodes as I explained in the previous ones, but here I'm just using the modifier. If I go into the geometry nodes, it's a little bit simpler actually. So let's go here. I also have different setups using a dual mesh here. I also have a different torus. I also have a triangulate, so you get like these banded hexagons. Looks a bit weird, but interesting. So let's turn this off. So I'm using a torus and a dual mesh. I'm capturing the edges plus 1, so I'm not capturing the 0. To do the same thing, to be able to subdivide, and then, because if we look here, you see that there are a lot of faces building up one face, so you get more like this curved feel as we see here in the photo, that we get this curve. And that's why I need to capture the edges. So here I'm using it to split the edges. So if I make again a viewer node, oh, it disappeared. Let's make again a viewer node and then go into split edges. So here we can see subdivision. Then I split the edges. You don't see it really, but it's taking like these edges to split them. Then I'm capturing the normals again. I'm extruding the mesh with a 0. So these, if I go into here, like these edges I am extruding for every group of faces here. And then I'm extruding them by 0, so you still don't see anything happening. Then I'm merging them together. Like here I do it by taking the top and then merging only that by distance, and then you can take the whole panel and the extruded edges and making them one again, instead of having all these separate elements. Then I'm setting the position to the normal that I captured here. I have to capture the normal here because if I use the split or the extruded normal, then you can see what happens. I get this, let's see which line it is. It's the top line. You see that they don't take the right normal because it doesn't remember what direction the edge was going before I split the geometry. So you need to capture the normal here. Let's delete this one. Now I split the top edges again and then smooth all the angles by 30. So you get this nice surface that is very smooth. And I can also, if we go here, give it more geometry to make it even smoother. But then now also these are the bolts. You can see what I do here. Capture the normal again, delete geometry. Let's go over here with the viewer node so we can see again what I've done. Delete. First we have this, then I'm deleting all the geometry except for these lines. And then I'm extruding them again with capturing the normal again, so the direction is correct. Then I'm deleting all the faces and then I'm capturing the normal again. Then mesh to points, so I'm getting a point cloud, or point cloud, it's kind of a point cloud. All these points are becoming bolts. I'm having here a cylinder again and I'm projecting the instances onto the points. And I'm aligning the normal to the Z again with the normal vector. And now it's set to have this connected to the subdivisions. You can also split it, like do this, make a separate subdivision so I can control it by these subdivisions. So you can put less or more bolts. And then when I turn on the geometry modifiers, then you get this effect. And here you can see now I have control over the bolts separately. This is not really a tool, it's just a node setup. Maybe in the future I make it into a tool, but for now it's easy to make it yourself, or you can get it on Blender Market if you don't want to build it yourself. So I hope this is useful, and I hope to see you in the next one. Okay, bye!